Okay, so my name is Dr. Rach Cook. I am going to be telling you a little bit about nitrogen management in Southern Illinois, if I had a clicker. Yeah. Okay, so Emerson showed you some data sort of pertaining to this. So I put the little U of I symbol up there too, since Emerson and I were working on this together. But this was funded by NREC, and I'm very excited to be part of this organization and to be contributing to new knowledge for nutrient management in Illinois. So who am I? A lot of you probably haven't seen me before. I grew up on a cattle farm in southernmost Illinois. Is anybody from farther south or equal to Johnson County? I win? No, there's one. Okay, usually I win this competition. So that's me and my dad herding cattle on our farm. I did my BS in biology at St. Louis University, and then did my master's and PhD at North Carolina State. Worked at BASF for a short while, and then came back to Southern Illinois when there was a position open at SIUC. So I've been there for 2 years now. Just to give you an overview of some of the kinds of things that I'm doing, I have a couple cover crop projects. One of them is also funded by NREC, working with Emerson and Maria at U of I. And then I have another one funded by the Agronomic Science Foundation. Those are two of my grad students. We're looking at how cover crops affect yield, soil nitrogen, and also doing some interesting stuff with how rooting biomass might be contributing to reducing compaction. So I've already ruined one undergrad on taking root biomass samples. He decided he didn't want to do grad school anymore after that. But we're doing some interesting stuff with that work. One of the other projects I have going on, Cameron mentioned what a meta-analysis was, which is taking all the peer-reviewed literature and figuring out what's going on. Through IPNI, the International Plant Nutrition Institute, I'm looking at how enhanced efficiency fertilizers, so urease inhibitors, nitrification inhibitors, polymer-coated fertilizers, affect yield, nitrate runoff, and nitrate losses, N2O emissions and nitrate losses in the Midwest. I liken it to, has anybody put together a desk out of a kit before? You know, it has the instructions and all the pieces and you have to put it together. Imagine you had a different piece from different kinds of desks from all different kinds of stores, and you're trying to put together a desk with baling twine and duct tape. That's kind of what it's like. It's sort of a mess because all the papers are very different. But I should be finishing this up by the end of the month, so hopefully at some point I'll be able to tell you about more of the results of that. Also, the stuff Shalimar and Mark David are doing will be wonderful because there's very few studies on nitrate losses. Very, very few studies on nitrate losses. So I'll be excited to see that. If you have seen me speak before, you've probably heard me talk about the long-term tillage by fertility study that's in Belleville, Illinois. I've kind of been on a circuit talking about that. I have a new grad student who's going to be working with me to look more into the details of some of the soil characteristics here. So that's been a great project. Okay, so just to give you an idea, that's the kind of stuff I'm working on. So back to the late nitrogen management project. It's funded by NREC. So the main purpose of this study was to evaluate options for late nitrogen applications and the effectiveness of urease inhibitors. And in this case, we're using agrotane. And also to evaluate the soil residual nitrogen afterwards. So there might be some concern that if you put on nitrogen later in the season, if it's dry, maybe that nitrogen isn't taken up and then could be a source for nitrate losses the following winter or spring, right? So we're looking at the soils as well. So we put in sites in, where's my little, yeah, there we go. So we've got sites in Carbondale and Belleville, and then John Pike helped me install some sites in Dixon Springs. And then Emerson got some sites installed in Brownstown, and then Perry, Illinois as well. Perry's kind of, I don't really consider that Southern Illinois. And the results that he got from that were a little bit weird, so I'm going to concentrate on the other ones for this talk. Okay, so what does late mean? For some of you Northern Illinois people, late might mean at planting. For us down in Southern Illinois, late, at least in terms of this project, means V9, V10. Okay, so when I'm talking about late, and I also threw in a V6 side dress application in here too. So the different treatments we have are one, just the basic in-rate curve to see for our other treatments, did we hit close to the optimum nitrogen? Are we below? Are we above? And so we have some at-planting treatments with and without Agritane with UAN broadcast. We also put on ESN at planting. So all those are at 150 pounds per acre. Then for our split treatments, we put on 50 pounds of nitrogen per acre as UAN broadcast, just right at planting, and then came back later and put on the rest of the 100 pounds either at V6 with the Sidedress applicator, which I just bought this year, which was fun. So Sidedress, UAN injection, and then the other treatments were all at V10. And so we had urea versus UAN, and then both of those alone or with Agritane for urease inhibitor. So the urea was broadcast over the top. The UAN was dribble applied from a streamer bar. Okay. So why are we talking about, why do we care about late nitrogen applications? One could be if you had extreme rainfall in the spring, you might think, well, maybe I lost some of my initial nitrogen, maybe I need to put on the rescue treatment later. But this was more looking at, can we spread out our nitrogen more over the season to give ourselves some better management practices to apply the nitrogen when it needs it most. So everybody knows that the corn is not taking up nitrogen when it's this big, or at least not much, right? So it gets really cranking once you get in past V6 and up into around the V10 stage, it's really cranking, taking up a lot of nitrogen, right? So if we can put that nitrogen on right when the plant needs it, then maybe we can be more efficient, get more into the plant. So this is a nod to Howard Brown for his acronym on what we're really trying to do is to maximize yield, to optimize in utilization, and then to minimize environmental impact. I think everybody is aware of the specter of regulation coming on. So we're going to have to manage our nitrogen better, right? So I asked my class, I had a current topics class this last semester, and we talked quite a bit about nitrogen regulation. And we talked a lot about volunteer programs, and I asked them to raise their hands and said, how many of you think we're going to fix this problem with volunteer programs? And nobody raised their hand. And I asked, how many of you think that we're going to get regulated? And they all kind of, with a very sullen look, raised their hand. So if we can do better, maybe we can head that off at the pass, right? So I'd like to be optimistic on this. Okay, so why urease inhibitors? So let's review why we use urease inhibitors. I had one student in my class last year that they put Agritane on their urea and then promptly incorporated it. And she said, wait, so we don't have to do that? Oh, so volatilization is a problem for urea that is put on the surface, right? So all of you probably already know this. So it's a problem because the urea gets attacked by the urease enzyme, which is excreted by bacteria, right? It's just very ubiquitous in the environment. That urease attacks the urea, breaks it down, and where it can be volatilized as ammonia, right? And certain conditions make that happen faster. So the urease inhibitor grabs onto that urease enzyme and sort of inactivates it, right? So that buys you a little time. So the volatilization process depends on a couple factors. One, soil moisture. So if you have moist soil that is sort of rapidly evaporating, that's going to cause more volatilization, okay? So that hydrolysis reaction doesn't happen very quickly on dry soils. So moist soils, warm soils that are evaporating quickly, lots of volatilization, okay? And so you need the rain to come in and dissolve the urea and push it down into the soil. So that doesn't mean that that reaction isn't happening in the soil. It just means that once the urea is broken down, and it might form ammonia, but as it tries to escape towards the surface, it's going to get grabbed by water, basically, right? Just like anhydrous ammonia. Okay. This reaction also happens faster when you have a higher pH. So the rule of thumb is if you have limed within the last 3 months with maybe 2 or more tons of lime, then you don't want to be surface applying urea. Okay, that higher pH makes the reaction happen faster. So that's just a rule of thumb. Everybody already knew that, right? Okay. Just a review. Okay, so I threw in a little high risk, low risk table in here. So high-risk conditions, high soil temperature for volatilization, high soil temperature, moist soil, high soil pH, also low cation exchange capacity, because that ammonium, positively charged, has to get grabbed by what? Soil particles, right? So positive, negative charge. So that ammonium gets attracted to soil particles, less likely to be lost, right? And then more crop residue. If you have more crop residue, you have more organic matter, you have more bacteria, you have more urease enzyme, right? Okay. Other little rules of thumb, if you are in a heavy residue situation, like we were, so these sites were all no-till that we worked on, so Carbondale had very heavy residue. We had pretty heavy infestation there. And then this is also pretty heavy residue. Both of these are no-till. So you would want more than ½ an inch of rain to wash in the urea. If you have less residue, you can maybe get away with a little bit less rain to wash in the urea before you get volatilization. So that's why we harp on rainfall so much. So this is just a little summary of the amount of rain we got within a week after each application for each site. Because you want to say, okay, did we get enough rain at each site that we're probably going to see, are we maybe going to see volatilization, or did it get rained in? So at planting, Belleville and Carbondale both got plenty of rain. Dixon Springs did not get rain the week following after our at planting, but the week after that it got a ton of rain. For the side dress injection, I'm not as worried about because you're already putting the urea, the UAN below the surface, so that's not as big of a deal. But for the late in planting, we really, I don't know if you want to say we lucked out or if it was just a good year, but we got more than ½ an inch of rain for all sites after the late planting. So if we'd gotten no rain at all after the late in applications, we may have seen a very different story, right? Which is why we have to do these studies year after year to see what happens in the different conditions, right? Okay, so what you actually want to see are the yield results. So I tried to keep this consistent with Emerson's sort of notation so that it looked nicer and was easier to follow. So I used the same price of N and the same price of corn that he was using, so everything was consistent. So these are the N rate curves. I'll show you the N rate curves first, and then I'll show you how the different treatments compared. So for us at Belleville, our late N treatments, the 150 pounds, was right about at the optimum N treatment. So we hit it pretty close in terms of guessing about where the optimum N treatment would be for that year. And just to remind you for Belleville, so plenty of rain all the way down. Okay, so what did we see in Belleville? So ESN topped our charts. So basically, if you remember from your statistics class, if things have an A following it, they're the same, which are different from the ones that have a B following it, which are different, right? Okay. So all the ones that have an A were our sort of top performers, so they're statistically equal, right? So ESN came up at the top here. Urea at V10 with Agritane right below it, but remember statistically the same. UAN V6 injection came next, V10 urea without Agritane. So basically that Agritane didn't buy you much of anything, right, in that case, which makes sense because we got rain right afterwards. Where was I at? Then the UAN at planting, again the same like Emerson saw in some of his sites. So at planting UAN was about the same as some of these later applications. With and without Agritane, essentially statistically the same. The ones that came in with lower yield were the late UAN treatments, with or without Agritane. So UAN appeared to not do as well for the late treatments compared to the urea. The urea for the late over-the-top treatment did fine, no problem at all. But the UAN in the later treatment, not quite as good. So just based on this one year, this one site, that UAN didn't do quite as well as urea for the later treatment. And we originally thought that we'd need to go look for plant injury and all this kind of stuff, and there really wasn't hardly any plant injury to speak of. So that really was a non-issue. Okay, so remember those results, all right? So UAN didn't do quite as well. So now I'll move to Carbondale. Carbondale had a weird sort of N rate response curve. It never did quite plateau out, which actually kind of makes some sense because another in-rate trial I had, the optimum, it sort of leveled out after about 200. We had a good year at Carbondale this year. So that's why this response curve is linear. So we fell a little bit behind the optimum in for Carbondale, but that's okay. So again, remember Carbondale, we got over an inch of rain the first time, hardly anything for the side dress, and then plenty of rain for the third. Okay, so what did we see? Something completely different, of course, which is good because this is good job security for people like me. If we had this all figured out by now, I'd have to go do something different. So that's okay. So best treatments, like in Belleville, were the late urea treatments with or without agrotane, ESN. Side dress injection sort of fell in between, so when there's an A, B, it's kind of the same as A and kind of the same as the B's, right? So side dress injection kind of fell here in the middle, and then the ones that didn't do quite as well, and you can see there's a pretty big difference at Carbondale between 128 and 175 bushels per acre, so pretty big spread there. So the ones that didn't do as well, broadcast at planting, which may have to do something with the large amount of residue that we had on the surface at Carbondale. Maybe immobilize some of our nitrogen. And then again, the UAN, the later UAN didn't do as well. So UAN, both at planting and the later treatments in Carbondale didn't do as well, which surprised me. I really thought UAN and urea would do about the same. Okay, so we'll do just a little bit of Brownstown too. So Dixon Springs, pretty close to the optimum in rate there. Dixon Springs, again, remember, nothing in the first week, lots of rain in the second side dress, and then over an inch for the third late treatment. So we had a pretty good year. Everything's the same. So sort of left me scratching my head a little bit. When I saw the rainfall, I was like, oh, definitely we're going to get a response from the agrotane this time. No. So now I'm thinking maybe next year what I need to do is also take some soil moisture readings when we put down the urea. So soil moisture is one of the things that determines how much volatilization you have. Maybe if the soils were kind of dry when we put it down enough, maybe that affected it. So numerically speaking, the urea, the V10 urea sort of came out towards the top again. And ESN came out towards the bottom, which was kind of, ESN had been sort of more towards the top on the other ones. So we'll just have to keep doing this again a few times until we figure out more what's going on. But again, like Emerson said, you could get something different every year, right, depending on weather conditions. So if you can tell me what the exact rainfall pattern is going to be that year, then maybe we can tell you exactly what nitrogen to put on, right? So anyway, this is pretty interesting. Last one, Brownstown. Our N rate was right there about the optimum N rate. Like Emerson said, Brownstown did quite well this year. 10 minutes? Okay. Especially considering Brownstown typically doesn't do as well. They got an entirely different pattern. So guess pick which one you're closest to. So they had best UAN with agrotane at planting, and their worst one, which surprised the heck out of me, was the V6 injection. So Steve Eberhard, I know, people are shaking their heads like, what? So I wasn't participating in this, so I can't tell you exactly what the conditions were like at this field plot, and they used different equipment than we did, so, and I just got this data, so I don't have the rainfall. So the rainfall might explain something going on here as well. So if that doesn't confuse you enough. But anyway, this is something we're going to keep doing, hopefully for the next 2 years, and if we can pick out more trends, then maybe we can have a little bit better idea of recommendations. But one of the main takeaways here, I think, is that the urea at V10 did just fine. So there doesn't seem to be any problem with doing that, so long as you get some rain afterwards, right? So that to me was one of the takeaways, and the fact that urea did a little bit better than UAN was a surprise to me. Does that surprise anybody else? No? Everybody thinks that that's okay. Steve Ebelard, the old agronomist at Dixon Springs, he had noted, well, I talked to him about it, and he thought UAN tended to not do as well in later applications. Maybe because of the surface area, but I don't know. So that's just the overall summary if you take all the sites together. Okay, so I looked at them across the different sites, and then if you clump them all together, our urea, our later application urea, our ESN, and our V6 injection tended to do the best. UAN at broadcast tended to fall kind of in the middle, and the UAN dribble tended to do the least well. Okay, so that's what we got out of the first year. All right. Just a quick going over for the soil results. Nothing hugely surprising here. So we evaluated soil nitrate and ammonium in the top 6 in 0 to 6 and 6 to 12 inches, and we did that prior to fertilization, prior to the V10, and then post-harvest. So we wanted to see were all the plots similar to start with, and then did we have much residual left afterwards, right? And then how much nitrogen was kind of left after that initial 50-pound treatment before the V10 treatment. So the pre-fertilization levels, pretty much everything was the same, so that's good. We kind of want to start out with a clean slate. In general, the Belleville site had more soil nitrate. It's a little bit higher in organic matter, so that's totally to be expected. At the V9 level, the Dixon Springs treatments had the highest, treatments had the highest soil in, at planting. So that makes sense because the ones that got the higher nitrogen treatment at planting had more at the V10, but they didn't get more anyway, so they just had enough. The weird thing is that at the Carbondale sites, the plots that got 150 pounds in the beginning had the same amount as the ones that got 50 pounds in the beginning. So that doesn't make much sense. They should have more because they got more nitrogen. So that sort of makes me wonder if that high residue content maybe immobilized some of the nitrogen. I don't know. That was sort of weird. And then post-harvest, everything was pretty much the same, except there were a couple weird treatments with the urea, the late urea at Dixon Springs that had really high levels. They were like 2.5 times more than the next one down. So I wonder if that wasn't a mistake. If it's true that that's what it was, then that means that there was almost 40 pounds of in the 6 to 12 inch layer, which is a lot, right? While the other ones were more like 6 pounds of in. So that seemed a little bit of an oddball. Okay, so just to wrap up, so with enough rainfall, the late application nitrogen and the ESN were feasible alternatives to everything at planting, right? So they did totally fine. The late application urea tended to do better than the late application UAN, and the urease inhibitor didn't do a whole lot this year because we had more or less enough rainfall, except for Dixon Springs, which is sort of a weird situation. And then in terms of the soil nitrogen, as long as there was enough rainfall, the plants were able to take up pretty much all of the N that was there and left very little behind after harvest. Okay, so if we'd had no rain towards the end of summer, it might have been a very different story, right? But this was a good year, and we had good results with everything. Okay, so that's thanks for your attention, and thanks to NREC for making this project possible. And with that, I'll open it up for questions.